Welcome to Study Loop.
This is chapter 21, problem number 72. We have two loops like this in the figure, and when the switch S is closed on the first one, we're asked to determine what the direction of the induced current in the other loop is. So the direction of the induced current in the other loop. Let's start with what happens when we close the switch here, right? When we close the switch, then the current through this first loop is going to start flowing clockwise, right? Generating a B field inside the loop. From the right-hand rule number 1, align your four fingers in the direction of the current, clockwise direction, and your thumb is going to show you the direction of the B field generated by this current into the board on the inside. However, on the outside, it's going to be in the shape of a ring around the loop, right? So on the outside, it's going to be out of the board. So then from zero current to clockwise current on the first loop is going to generate from zero B field to a field that is out of page on the outside that the second loop is exposed to. So the second loop is going to experience a flux, increase in flux out of the page, right? So then it's going to want to generate at the counteract this increase in flux. So it's going to want to generate the B field that goes into the page, that therefore generates the flux into the page. Then only way to have this sort of B field and into the page flux for the second loop is by having a current that is in the clockwise direction. And how do I know that it has to be clockwise? It's because the direction of the B field, again, right-hand rule number 1 tells you the direction of the induced current if you know the direction of the B field, right? So then you can align your thumb with the direction of the B field for the second loop. I'm talking about this, right? So it's into the page, and then the rest of your fingers, if you curl them along this loop, then you're going to see that your fingers, the tip of your fingers, are going clockwise. Therefore, the direction of the induced current is going to be clockwise. Now, part B, then. Part B, what is the situation after a long time? So after a long time, after we switch, we close the switch is the question. So then initially the flux changed at that moment where you close the switch, but then within actually a short period of time, you're going to have a certain flux. Flux is not going to change for the second loop with respect to time. And if flux is not changing for the second loop with respect to time, then actually no induced current on the second. No induced current on the second loop, right? Because no change in flux. After a long time, your current is just constant on the first loop. All right? So part C. What is the direction of the induced current if the right loop is pulled horizontally to the right? Now, what we're doing is we're pulling this second loop to the right. What happens to flux? Always this is the question, right? What happens to flux if we move the second loop to the right? The strength of the B field generated by the first loop is going to decrease as we get away from that particular loop. So B field is decreasing as we pull the second loop to the right. Also, flux is then decreasing, right? Flux, but the direction of the flux is still out of the page, right? Still. So let's say out of page flux is decreasing. So if the out of page flux is decreasing, the loop wants to oppose, right? Loop opposes, which means it's going to reinforce the flux out of page flux. So, which means if the loop is going to reinforce that, so it's going to generate this B field that goes out of the page so that it can balance out the decrease in that particular direction. try and balance out. Of course, it's not going to be totally balancing it out. So then if this is the direction of the induced B field, then again, using your right-hand rule, number 1, line your thumb in the direction of the B field, that is out of the page, and then the rest of the tips of your fingers, they're gonna be following this circular loop. So then you're gonna see that the direction of the induced current in this case is going to be counterclockwise, right? Counterclockwise. Let's put it here for the answer to part A is clockwise. All right. Now, there is one more part to our problem, I believe. So part D, let's go on a new page. Part D is asking, suppose the right circuit, the right loop has a switch too. So the left one has a, remember how it had the switch here, something like this, but it has the battery here. The right loop doesn't have a battery, but apparently this time it has a switch that goes like this. Call it S prime, this is S. Assume that the right loop has a switch. Switch in the left loop has been closed a long time. So we're not interested in that moment where we close it. It's been closed for a long time. So don't worry about it, which means the current is constant. I is constant. That is flowing through the first one. And the right loop is closed. What happens in this case? So when the current is constant on the first loop, if we close the switch on the second one, what happens now? There is no change in the flux. I is constant in the first loop. There is no change in the flux. There is no induction. So then closing the switch on the second loop has no effect whatsoever, right? There is no induced current in this case.